Welcome to the last class of Embryology, class 6, which is the third class for Colloquium 2. We are gonna talk about in this class the eye and its derivatives, such as the eyelid and orbital bone. We're also going to talk about the head and sagittal section and its own structures, such as the ear development, inner ear, late tooth development, as well as some glands. All right, let's start. Let's begin with the inner ear development. Now, this is a separate section of the inner ear. I would say most often than not, the slides that are in the Anatomicum are of these sagittal section of the heads, and then they zoom in to show you the inner ear development instead. But let's look at this first, and then we're going to get to what it looks like in a more advanced slide. So for the inner ear development, usually the list of structures changes depending on which professor is teaching you. So for example, here, for my professor, Professor Rone, she only asked us to remember the developing cochlea, the cartilaginous ear capsule. Obviously, if we have like a nerve, we need to know about what kind of nerve it could be, and then maybe the spiral ganglion, but honestly, it wasn't that important. There are some other structures that I would like to go through, such as the ampulla, the crista, as well as the semicircular canals for this specific section, but we can't really see it here. We can't see the semicircular canals, we can only really see the helicotrema and the different scalas of the developing cochlea. But an important note here is that everything that surrounds the ear, like the walls of the ear, all of that is called the cartilaginous ear capsule, and it's one of the more important structures for the inner ear. For example, if we look at this head in sagittal section and we zoom into the ear, all this blue area that sort of looks like hyaline cartilage, it really isn't, is the cartilaginous ear capsule. So just write that down if they ask you about that area. Well, all of these circles that we have here, the smaller ones, are known as the semicircular canals. And the semicircular canals can also be very elongated. They don't have to be this round. But in this case, it would be safe to say that all of these smaller openings are the semicircular canals due to the size difference between this and the cochlea that we see here. Now, the cochlea has this characteristic three opening shape. It has like a bow shape, right? It has this little knot in the bottom and then the two wings of the bow, or a fly, if you may. So if we go back here, we can actually see that characteristic bow shape with the knot in the center and the two wings extending like so. So that makes this the developing cochlea, which is a structure that we went through in this seminar for histology before the colloquium 3 topics, I believe. Okay, so what is this big opening then? This is known as the ampulla, or developing ampulla, and it hosts this inner sort of lens shape structure known as the developing crista. Some professors think that it is an important structure, others don't. It really comes down to the availability of slides as well as what the professor expects you to know. If you write in semicircular canal for this one, I'd say if the professor is nice, probably you'll get some points. What I would have done is with the smaller openings, I would have gone with semicircular canals, the ones that look like a bow, developing cochlea, and the large one with like this little tissue in the middle, being the developing ampulla. But again, it all depends on the person. If you go with developing cochlea for all of them, you could gain some points just by the mercy of the professor as well. But the cartilaginous capsule is still an important structure to note. And here I don't think we can find the nerve ganglion. I think sometimes you can even see the trigeminal nerve here, but it's not visible for this slide. So let's continue on. I've written down some pages that we're gonna zoom to in order to see some more of the ear or inner ear development. For example, here. Now, if we erase this, boop, boop, erase it for a second, just so that we can have a clear view of this. Perfect. Here we have the developing inner ear. Now, like I said, what is important for you to note when you're in the face of a creature is that you can actually see the tongue, and then from that you can make out the fact that you're at the head area, right? So maybe they're going to talk about the brain. Highly doubted, because we don't really see the eye. Go back to the previous class if you want to see what that looks like instead. They could talk about the skin, they could talk about like other parts of the face, but most likely they could also talk about the inner ear. Now here we can see that the inner ear, again, placed where the ear is, should be, behind the tongue, like so, and then we can see all of these smaller openings right here. Now, what we got here, I would say this elongated structure here could be a semicircular canal, while this little bow, we can kind of see it here. It has this knot, and then the wings here and here, and the stereotypical helicotrema at the top. Because it's so symmetrical, we can also see it on the other side. This is the developing cochlea. And then this larger opening with a little thing in the middle is the developing ampulla with a developing crista in the center. That is how I figured out the ear. Let's carry on to the next. Here we go. So here we have another ear. And like I said, we have this bone structure, not to be confused with the start of the developing vertebral column. And we can see here the helicotrema, which looks almost like a burger, I would say. So we can't really see the developing cochlea, because it would be some structures down here, which it's cut off at a specific point, so we can't really see. The helicotrema is the top of the inner ear. So remember how the inner ear looked kind of like a snail? So the top part is the helicotrema. So the bottom part, we can't really see it, and therefore it's not annotated here. But in this case, they would maybe ask you about the cartilaginous capsule. They won't ask you about the helicotrema, I don't think. Okay, moving on to page 88. Here we go. Here we can see the small semicircular canals development, which I said are these small openings, very circular, within the cartilaginous capsule. And we can't really see any other structure. Why couldn't these be the ampulla? Well, because there's two of them, and because we can't really see the characteristic like crista of the ampulla, I would go with semicircular canal. Again, it's very wishy-washy, and it all depends on what the professor wants you to know or write. Let's carry on to 89. Okay, we went through that, perfect. And then to 90. Here we have another large section of the inner ear, and we can see here that we have those little bows. Do we actually have the little bows? I see actually an ampulla here with a crista, so I haven't annotated that. But this would be a good example of the ampulla with the crista, because of the characteristic little little dot in the middle. It kind of looks like an eye, right? This perhaps would be the developing cochlea. It's very oddly cut, so I understand why I just annotated the whole thing as the developing cochlea. But again, minus this might just be the developing ampulla. And then we have the semicircular canals, which you can see in comparison with this monstrosity is very small and very circular, so perfect for the semicircular canals. Just remember to write in developing before. Sometimes I forget to do that as well. And then the blue part in this case is the cartilaginous ear capsule. Now this is what the ear looks like under the microscope. Let's first talk about what we see in the surrounding regions of the ear. This is a very, very fragmented eye development. We can see some hair follicles within the epidermis there underneath the eye. So most likely than not, there's a tongue close by. This is late tooth development. This is also late tooth development. And then further on to the left, if we continue, we can actually see the inner ear development right there and there. So these are part of the same slide. They're just showing you different sections of it. Here we can see the cartilaginous capsule of the inner ear. We can also see those smaller semicircular canals. While here we see the helicotrema, and we can kind of see the fragmented developing cochleas as well as the developing ampulla. Now this is the microscope version of the slide that we just saw previously. Right, nope. Give me a second. Right there, perfect. That it's the same slide. This one is just very processed, so you can actually see the entire thing. While here we can only see it in a more zoomed in format. But yeah, that's kind of what it looks like. So if you see this hamburger like little shape with the, maybe it looks like a hot dog, actually kind of looks like a hot dog. This is the little hot dog and then the bun next to it. Underneath is always the cochlea, and then we have the larger one with the crista in the middle that kind of looks like the developing eye, and that is the ampulla. And then the smaller ones are the semicircular canals. Hope that makes sense. Finally, let's talk about the eye development. This is a slide that is quite large, and it's not really that good for the colloquium because it's missing a lot of the structures that we do need to know for the colloquium. But let's go through it. It's a good section of the eye still. So first of all, the most identifiable, most prominent part of the the eye in cross section is this lens that we have here, the developing lens. And the developing lens have these fibers that look like striations, like so, and these are known as the long lens fibers. And at the top of the developing eye, towards the outside section, so all of this is called the anterior cuboidal epithelium. Those are the three names that you have to remember for the developing lens. Then there is a little dark layer that kind of extends towards the corners of the eye like this, or the top of the eye. The longer layer kind of looks like a vanilla bean little twig thing, is known as the ciliary body, and it has these branches that extend like so, sort of like snakes, that are known as the ciliary processes. We can see it at the bottom as well. This would be the ciliary body, and then this is the ciliary process. So be careful with which of the part of the section that they're actually showing you. Is it the processes or is it the entire body? We're going to get to the chamber in a second. I would like to actually show you the posterior and anterior chamber in one and the same image. We can't really see the posterior here. And then on top of the lens, we have this layer known as the cornea. Now, a lot of people mix up the cornea with the eyelid. The layer that is immediately in front of the entire lens is known as the cornea. Now there is an additional layer here that might be the eyelid, but that is, sometimes that can appear, other times not. We are going to cover it though in this colloquium. But the first layer that is in front of the lens is the cornea. There are also layers to the eye. For example, the neural retina, which in this case is subdued towards the corners of the eyes. Sometimes it's just floating like this, almost like a snake, which very much looks like the neocortex from the brain development. So a lot of people make that mistake. Let's show that to you guys before I continue. Here we go. This would be the neural retina. All of this, like I said, it doesn't have to be completely like subdued towards the corner of the eye. It could also just be within the center, like so, freely just swimming around there, right? And this looks very much like this, only this is a lot larger than what this is. So if you find yourself in the eye and you see that characteristic lens and the cornea in front, and they ask you about this, they zoom in and ask you about this, as soon as you remember, well, I did see the lens previously, so even if they zoom in and you can't really see the lens and they ask you about that, you will know that you're in the neural retina. While here, you won't see the lens here, right? That belongs to the eye. So as soon as you see this and you see a lot of like brain tissue and brain matter, then you'll know that this is actually the neocortex and not the neural retina. That is a mistake that a lot of students make, unfortunately. Okay, going back, here we can actually see that the neural retina is attached to the corners like so. And then we have the pigment retina, which is just a very darker section of the eye like so. I can show you to you in a more detailed, there we go. All of this is the pigment retina. It sort of develops into the ciliary body. So here, for example, you can see all of that is the pigment retina, and then it gets to the point where it becomes the ciliary body, and then extending from it is the ciliary process. We also have an additional section underneath the pigment retina. So if we zoom in here, this would be the pigment retina, all of that black area, right? And then we have a layer underneath, directly underneath, known as the choroid. And then another layer underneath that is a lot lighter, known as the sclera. Now let me show it to you in a more zoomed in manner so that you can actually gain the difference. This is a throwback to the seminar task that we had for histology, but just to get a more zoomed in version, this would be the neural retina. That's why it looks like it has all of the different layers to it. And then this would be the pigmented retina that we saw previously. This underneath, the ones that have all of these blood cells that we can see here in the center, all of that would be the choroid. And then further down this area, you can kind of see it here, so that is the sclera. It's kind of like a bone-ish section of the eye, while this would be the choroid. So going back to this area, we can see here, we're back here. We do still have the pigmented retina here, that is this black line, and then underneath that, as soon as we see the blood cells and blood vessels like we do here with all of the blood cells there and the blood cells here, that is going to be known as the choroid. So if you're underneath the pigmented retina and they ask you about a section that is directly underneath with all of the blood cells, that would be the choroid. While the sclera is more of a, lighter tissue underneath the choroid itself. Let me see if we can actually find that more zoomed in. Here we go. So here we have the pigment retina, like I said, it's just this dark line that lines all around the eye. Then directly underneath the pigment retina, if it contains a lot of blood cells, is the choroid. And then underneath that would be the sclera. So like I said, we don't really have a zoomed in version of this section, therefore it's hard to show you that. But ask your professor for a visualization of that, and I think they'll grant you that request. Now let's get to the more important structures of the eye. I would say the neural retina and the pigment retina, as well as the lens and ciliary body, is a very important structure for this colloquium. But there are others that are equally as important. One of them is this area in the middle. It is the area between the neural retina as well as the lens. And it contains all of these smaller little capillaries that are known as the remnants of arteria hyaloidea. So write that down if you have Professor Vivats, because that is a structure that Professor Vivats has mentioned is still important for the eye. But the rest of the structure, all of this layer, is known as the vitreous body. And we can see it in every other slide of the eye. We can see it here. So this is the nervus opticus. The lens would be somewhere here. So in between here, we would have the vitreous body. But here we can see it more clearly. That would be the lens. That's the neural retina. And then we have that vitreous body in the center, as well as the remnants of hyaloidea right there. We have it pretty much in every eye. So lens, that would be the vitreous body, that would be the neural retina. Same thing here, lens, vitreous body, neural retina. I hope that is clear for you guys. Okay, going back, we have talked about the cornea, but I would like to talk about a structure that we rarely see. So like I said, there is a layer in front of the eye that is the cornea. And I said that it is usually the one directly in front of the eye. But there is a membrane in front of the eye that you can sometimes see. All of that thin membrane that is in front of the lens, right? And we can kind of see it up here as well. It has been, it's degenerating though, so we can't really see it completely covering the eye like so, or the lens. And this is known as the degenerative membrana pupillaris. So all of that little, very loose tissue that is in front of the lens is the membrana pupillaris that's about to degenerate, while the clear layer in front of it is the cornea. Now, an important part of the membrana pupillaris is that it helps you distinguish where the posterior eye chamber is. And the posterior eye chamber is always behind the membrana pupillaris. So remember when we looked at this and we could only see the anterior eye chamber? Well, that's because the membrana pupillaris, which maybe this could be it, not really, but maybe, that kind of determines the line between the anterior eye chamber here, this is the anterior, and the posterior, which would be that little area there, posterior. So behind the membrana pupillaris is the posterior eye chamber, and in front of it is the anterior eye chamber. So if they ask you, for example, here we have the membrana pupillaris here, and there's like a little slight opening here, empty space, that is right behind the membrana pupillaris, that is known as the posterior eye chamber. While every all the empty space in front of it is known as the anterior eye chamber. I think that was clear. So again, the cornea is then directly in front of it, and then there is the eyelid space, according to Professor Rone or according to Professor Vaivads. Oh, okay, I didn't know that was a feature. It's the conjunctival sac. So it is the space that is in front of the cornea, and it appears sometimes it doesn't. For example, here we don't have the eyelid here, so we can't really see that this is the conjunctiva sac. It could just as well be an artifact, right? But here we can see that the eyelid has been closed due to the proliferating epithelium. So this is the, I would say that would be the lower eyelid. This is the upper eyelid. And then we have the cornea right next to it, and then all of that space in between known as the conjunctival sac or the eyelid space. Again, appears only when we have that characteristic eyelid in front of the eye. So let's break this down again. We have the lens. In front of the lens, we have this epithelium. You see all of those dark nuclei known as the anterior cuboidal epithelium. And then right in front of that, we could sometimes have this membrane tissue area that is known as the degenerative membrana pupillaris, and it borders between the posterior eye chamber, which is the empty space behind the membrana pupillaris, and the anterior eye chamber, which is the empty space in front of the membrana pupillaris. And then we have this large section known as the cornea, not to be confused with the eyelid. And then if we have the eyelid, it is a much larger section in front of the cornea, and the space in between them is known as the eyelid space or the conjunctival sac. I think I think that's enough for the layers. Now let's talk about the eyelid. Now the eyelid has this slimier inner. You can kind of, know that the inner parts of your eyelid is a lot more moist, and that is because it consists of this developing conjunctiva part, which is a lot more mucus, so that it protects the eye and makes it very moist all the time. So that's the part that is on the inside of the inner eyelid. We have the lower eyelid and the upper eyelid. Let's just say this is the upper, just for the sake of argument right now, because I hate to rearrange it. Sometimes the eyelid is closed like this. So let's look at it without any annotations so that you guys can see it more clearly. Here we go. So, like I said, here we have that eyelid. This would be the cornea and this would be the eyelid. And here we can see that the eyelids have been sort of stuck together with this little glue, and this glue is known as the proliferating epithelium. So it is like a little glue that has been sticking the eyelids together, and that's because the embryo has closed eyes, right? So they don't really open until way later in the pregnancy, and therefore they have been stuck together with this proliferating epithelium, like so. It's almost like glue, and that is an important structure for this colloquium as well. We can also see the hair follicles, and this is how I figured out which one is the upper eyelid and which one is the lower. I just look at the hair follicles, because we all know that the upper eyelid has more hair follicles than the lower eyelid, right? So just judging by the sheer number of hair follicles here compared with the 3 that we see here, I can just safely say that this is probably the upper eyelid. When it comes to the eyelid, they can just as easily ask you about the layers of the skin. So they can ask you about the epidermis, they can ask you about the dermis, they can ask you about the blood vessels, they can ask you about the hair follicles, they can also ask you about the lymphatic vessels. It all could just appear in the eyelid, just as it can appear in any other skin slide. But there is a specific muscle that we do have to name if we're within the eyelid section of the eye. And that muscle is all of this in the center. Remember when we talked about the lip? Let's go back to the lip so that I can actually show it to you guys. So the lip also had a specific muscle that we had to name. Here we go. So this is the tongue and this is the lip, right? The lower lip. And here we also had the epidermis and the dermis, as well as some hair follicles and lymphatic vessels. But in the center, we have this muscle tissue in the middle. This muscle tissue is striated skeletal muscle fibers. However, because it's within the lip, we actually had to specify that this was the M. orbicularis oris. The next muscle that we have to specify is in the eyelid. It looks exactly the same. So besides the M. orbicularis oris, we have to specify the eyelid muscle. And the eyelid muscle has a similar name. It's known as the M. orbicularis oculi. So again, similar name, only that when it's in the eyelid, it's oculi and not oris, like when it's in the lip. And those two are the 2 muscles that we actually have to name and specify if it's the muscles that they actually show you. If you write in striated skeletal muscle fibers, you might gain points for it because it's technically right, but you won't get full points for it. And it's quite an easy muscle to name, to be honest. Okay, so let's go back here. Like I said, we can still have some skin, like the developing epidermis, the developing dermis, some parts of the skin that are still important. Okay, that was all for the eyelid, but let's look at it from other perspective. Here we have it. Let me look at it without any annotations. Here we have the same thing again. Let's start with the lens. We have the lens here, and see all of those purple dots in the front. Let me just make sure that I'm not saying it wrong. Anterior cuboidal epithelium. And then we have, let's say we have this little thin membrane. We actually do have it right there. And this thin membrane is known as the membrana pupillaris, or the generative membrana pupillaris. And it borders between the I believe the anterior, I haven't done this in a while, guys, sorry. So membrana pupillaris, the anterior eye chamber, as well as the posterior eye chamber, which is this little empty space right behind the membrana pupillaris. And then we have the developing cornea right there. And sometimes we can actually have the eyelid like we do here. And in that case, we have this conjunctival space or eyelid space in between, with the conjunctival epithelium that lines the back of the eyelid like so, and the entire eyelid, upper and lower, up here, with the different parts of the skin right there. We can see the hair follicles as well, and we can also see the M orbicularis oculi right there within the center of the eyelid, just like we could see with the M orbicularis oris in the center of the lip. Okay, and then all of this area at the back is known as the vitreous body, and these little tiny like blood vessel like structures is known, because I didn't have this in my colloquium, is known as the remnant of arteria hyaloidea. So do remember that if you do have Professor Vivat, unless there's a change in the structure list. And then we have the neural retina, which kind of looks like the neocortex, only we know that we're in the eye here. And then that black line that lines all across the eye is known as the pigment retina. Underneath with the blood vessel is the choroid, and then the sclera, which is a lot lighter area. And in between the two eyelids, sometimes we have the proliferating epithelium, which acts as a glue that sticks these two eyelids together. Sometimes we don't have that. Now, what the hell is this? Sometimes we don't have that eyelid proliferating epithelium. Sometimes we only have the eyelid separated, like we can see here. So that would be maybe the upper eyelid, and here would be the lower eyelid. So in this case, the eye is open. Okay, and then of course the nervus opticus, I believe that's it, besides the bone that is adjacent to the eye. So let's talk about that. So all of that hyaline cartilage, which you can see here, you can see it here, you can see it here, is known as the orbital bone. Orbital bone, or vacuolized orbital bone, but you can also write in hyaline cartilage. Some people or some professors accept hyaline cartilage with full points. Do check that though. That is my catchphrase for this series, I guess. So all of that hyaline cartilage is known as the vacuolized orbital bone, and we can kind of see it everywhere. Here we don't really see it. It would be somewhere here, sort of. Now let's look at the previous classes slides to talk about the eye development here as well. So like I said, when we talk about the brain development, 9 out of 10 times it's going to be a structure that looks like this. So in a slide like this, right, when they show you the eye, it's to signify that you're within the face and that they might show you the brain parts next. But they could also just settle in on the eye and show you some eye structures as well. So for example, we have the lens with the long lens fibers, we have the neural retina here, we have the pigment retina underneath the choroid and the sclera, we have the vitreous body with the hyaloidea, and we have the, I would say, anterior eye chamber maybe here as well. Here we can actually see the hyaline cartilage more specifically, the vacuolized orbital bone right there. There is another additional structure that you may not see always for these eye slides, and that is the lacrimal gland development, which is the duct part of the lacrimal gland. It's just a little duct that is right at the corner of the eye, closest to the end of the cornea here. So if you see a little opening there and they zoom in and it looks gland-like and it's close to the eye, and it's below the cornea, then it would be the lacrimal gland development. Additionally, this would be the area where we would have the nervus opticus. However, here we can't see it, but sometimes we can actually see, here we can actually see the nervus opticus. Sometimes we can see another type of nerve close to the eye, not behind the eye, because that would be the nervus opticus, but close to the eye. Here we go. This would be an eye development, and if we had the nerve here, starting from here and then branching out, that would be the nervus opticus. However, we have this little nerve ganglion here, and this is actually the trigeminal nerve. Looking at the demo lab slides for the eye, we can actually see what it looks like under a real microscope. So here we have the developing lens with the long lens fibers, the anterior cuboidal epithelium, as well as the membrana pupillaris, or the degenerative membrana pupillaris. Here we can actually see the posterior eye chamber, the anterior eye chamber, the developing cornea, which would be this entire thing, and then the conjunctival space or eyelid space, because we can actually have the eyelid here with the conjunctival epithelium at the back, the proliferating epithelium, which glues both the upper and the lower eyelid together. We have the didymis here. This would also be the didymis, the epididymis, the hair follicles, the M. orbicularis oculi, as well as the ciliary bodies that we can see here. This would be a ciliary body, and then all of these little wave-like formations would be the start of a ciliary process, I would say. Here we have, maybe this would be a ciliary process, and then this would be the ciliary body. The very last structure of the face that I'd like to cover is the nasal cavity development. Now, we had something in relation to the nasal cavity in class number 4, where we can see it here. This is a face, and we can see the tongue development here. So this would be the lower jaw, and this would be the upper jaw. Here we can see the Meckel's cartilage as well. But if we go towards the nasal area, we have these Wi-Fi signal looking structures or openings right here. So like I said, they appear almost like Wi-Fi signals, and these are known as nasal, and I can't pronounce this next word, so don't make fun of me, conches. I've never heard it being pronounced, but yes, so the nasal conches are these Wi-Fi looking openings for the nasal area. With the nasal cavity development, we actually have a lot larger openings here. It is more apparent if we scroll further up to see it here. So this is a section of the face. This is the eye development with a very, very large lens. And then we have the ear development, and then we have the nose. And here we can actually see that the nasal cavity development appears more flame-like. If you've ever seen like a flame-like design on a shirt or something with all of these individual branches of a fire, that's sort of how I would describe the nasal cavity development more clearly. And then we have the nasal or developing nasal mucosa, which is all of that. And within the nasal development, we also have the nasal cartilaginous capsule, just like we had with the ear cartilaginous capsule surrounding the inner ear development. We have the cartilaginous capsule of the nose, which is all of this hard, bony material within the nose as well. We can see the developing nasal cavity as well here with the respiratory epithelium or nasal mucosa, if you will, right there. And this would be the nasal cartilaginous capsule as well. And then further down, we still have it there. So pretty much in every face slide or embryo and sagittal section slide, especially for the animals, we'll see the nasal cavity more open like so, with the developing nasal mucosa and nasal cartilaginous capsule. Like I said, it's pretty much everywhere. So yeah, that is the developing nasal cavity. Now we're finally getting into the late tooth development. Now I covered this a little bit in class 4, but let's go into it a little bit deeper. So the late tooth development you'll be able to see in these total embryo and sagittal cut slide or separated head, just like this. And usually it's going to be in an animal embryo, because the late tooth development appears more frequently there, or it's more prominent there than in a human embryo head. So here we see it like so. We can't really see the dentin and enamel that well. Maybe the enamel would be the later area, but mostly just the entire late tooth development. And again, not to be confused with Meckel's cartilage, which we did cover in class 4. Please check that again in order to see a comparison. More likely than not, though, the late tooth development will be shown to us in a slide that has the dentin dyed blue. So all of this intramembranous ossification that you see here, all of these stripes, almost zebra-like stripes, as well as the dentin of the late tooth development, is dyed blue. And this gives us a more deep understanding of where the ossification occurs. So for the intramembranous ossification, it looks something like that. We can see it here as well. While for the dentin, we can also see it aligning the late tooth development like so. And here we can probably see that this is an animal tooth, even though, you know, it should be quite obvious, especially with these little whiskers there. But as you see, their teeth are within like a little conglomeration like so, and that's not common for human teeth. Then we have the enamel, which is this darker rim of the late tooth development, and can sometimes be a little bit more separate like we see here. This is also the enamel. In another slide that's similar, we can see it here. This tooth is very large, but we can still see the blue part, which is the dentin, as well as the dark part, which is the enamel. This entire thing, though, called the late tooth development, we have it here as well. But up here we have it too. So blue part, dentin, dark part, enamel. And then all of that stripe blue is the intramembranous ossification, which is something we usually see around the jaw area. Here we see it again. So these are the teeth. That's the intramembranous ossification, specifically late tooth. If you want to see a breakdown of the early tooth development, it is available for class 4. However, more likely than not, for the slides that we do have in the anatomicum, late tooth development appears more frequently. And here's how it looks like under the microscope. So again, this is the entire late tooth development. These are intramembranous ossification. And then we have the blue part, which is the dentin, and the much darker part, in this case, a very neon pink color, is the enamel. And we see it here as well. So the enamel is the pink part, the blue part is the dentin, and then all of it is just the late tooth development with intramembranous ossification surrounding it. We are nearly at the finish line, guys. Now let's talk about some organs and structures that we haven't covered in the previous classes, but are still important for this colloquium. One of the most prominent and dark organs for this entire embryo and sagittal section, almost in any slide, is the developing thymus, and it helps you orientate yourself in for where in the body you're located. So for example, if you recognize that it is a developing thymus, and it's quite recognizable to say the least due to its very dark color compared to everything else. Let's look at the no annotation slide to compare. Here we go. Like I said, the thymus or the developing thymus is very apparent in its color. And that way you know that you're in the like neck or upper chest region, I would say. So continuing on, either you'll see the lung, which is towards the bottom part of the slide, or you'll see the tongue, which is another signifier of where you're located. So other than the developing thymus, you also have the developing larynx, which is a set of bones towards the back of the throat near the back of the tongue. So if they ask you about bone development towards the back of the tongue, that would be the developing larynx, more likely than not. And finally, close to the developing larynx, still a dark color but not as dark as the developing thymus, is the developing thyroid. Now these structures were mentioned by Professor Vaivads more often than they were mentioned by Professor Rone, but I would say that both professors think that they are important structures for the colloquium. Let's look at other slides to find the same structures. So here, like I said, the developing thymus is very apparent. So zooming in, this would obviously be the developing thymus. Then towards the back of the tongue, we have a bone formation known as the developing larynx. Then close to it, also with a darker color, but not as dark as the developing thymus, is the developing thyroid. I don't want you guys to confuse the developing thyroid from the submandibular and sublingual glands, which you can find here. So if you know for sure that this is the developing larynx and they ask you about the thyroid, then you can write down thyroid. But if you don't really see the developing larynx and they ask you about structures which are here, these three structures, which we will end this class by explaining what they are, then just don't write in the developing thyroid, because these structures appear more in slides than the developing thyroid. These are, according to the professors, more important than the developing thyroid organ, for the colloquium at least. Here we can also see it as well, the developing thymus as well as the developing thyroid close to the developing larynx, which is at the towards the back of the developing tongue. Say that fast 10 times. We have the same thing here, the developing thymus. We can't really see the thyroid nor the larynx here as well, but here definitely the developing thymus is still very apparent. We do have the developing thyroid there, but we're missing a bit of the larynx, I would say. Here mostly the developing thymus is shown. And then here also just the developing thymus. So it all depends on the type of slide. But if we're looking at the head, we're probably not going to be talking about the developing thymus, thyroid, nor the larynx. So if we have a separate head slide, we're probably going to talk about these three structures when it comes to the neck / submandibular region. And we're going to get to these structures right now. All right, the developing sublingual gland, the developing submandibular gland, as well as the brown adipose tissue are three of the most important structures of this entire colloquium. So if there's anything you get or take from this class, I'm going to ask you to remember these three and the eye development structures that we went through. Those are the most important structures for this class. Okay, let's start talking about them. Now, these three look very similar, right? All of them bunched together like this, and we're going to talk about the differences in a second. First of all, let's talk about what the professors want from you regarding the glands at the very least. So, according to Professor Ronet, now this might change in the future, but you can actually just name these major salivary glands. They fit under this one umbrella, so you don't have to differentiate them. But Professor Vaivads says that you do, so we're going to go through the differences in a sec. The brown adipose tissue is probably the one structure that the professors stress about the most. So, which means that they want you to actually know about the brown adipose tissue before getting into the practical part of the colloquium. Now, a difference between the brown adipose tissue and the developing sublingual and submandibular glands is that the brown adipose tissue you can actually find in two areas when it comes to the slide. In theory, you can actually find the brown adipose tissue almost anywhere in the fetal body. But in this case, for the slides that we do have, we can find brown adipose tissue in two places. The first one being in the throat area, like so, and the second one being towards the back area, so something like this. So you can see the developing vertebral column here, and these would actually be the brown adipose tissue, not to mix them up with the striated skeletal muscle fibers, which you can also find towards the back of the developing vertebral column. We're going to get to the differences in a sec. So like I said, for brown adipose tissue, you can find it in two areas, towards the throat area or submandibular area, as well as the sagittal back area behind the vertebral column. You can see it here. And when it's within the throat area, it's easy to mix them up with the sublingual gland as well as the submandibular gland. But both of these have these structures, these serous and mucous acini with lumen, while the brown adipose tissue, while it does seem like they have these openings inside them, these are actually lipid or lipid inclusions or white adipose tissue as well. We can also see here we can also see the zoomed in version of brown adipose tissue, which we unfortunately don't have a microscope image of that is super clear, but this is what it would look like under the microscope. And what is important is that we can identify the white adipose inclusions that can be among these brown adipose cells, as well as the lipid inclusions that are within the brown adipose cells. So you can't really see any sort of serous or mucus acini or glands here, which you definitely can see in the sublingual and submandibular glands. It's just these brown adipose tissues with the lipid inclusions, or even the white adipose cells that are scattered about. Here you can also see it as well, more pixelated, but nonetheless, these are the white adipocytes, and then all of the rest of these structures are the brown adipose tissue with the lipid inclusions. Here's another example of where the brown adipose tissue can be found. So this would be the vertebral column, or the developing vertebral column, and then behind here we can actually see the brown adipose tissue. So an important fact is that usually they'll either zoom in for the submandibular part in order to show you the brown adipose tissue, or they'll show you the vertebral column, and then if you recognize the vertebral column and they go towards the back of the vertebral column, showing you an area where you would usually find striated muscle fiber, skeletal muscle fiber, they can also show you the brown adipose tissue. And more likely than not, for this colloquium, because the brown adipose tissue is such an important structure for this colloquium, if you are weighing your options between the immature skeletal striated muscle fibers and brown adipose tissue, and you find yourself towards the back of the embryo, I would hedge my bets and go with brown adipose tissue. That is, again, only if you find yourself towards the back of the embryo, or even like in the mandible or submandibular area. But of course, the striated skeletal muscle fiber structure is still a structure that's important for this colloquium. For example, if they show you the cells within the tongue, which is obviously a skeletal muscle in and of itself. It's important to not confuse the brown adipose tissue with these three structures. Now let's start with the sublingual gland, and let's talk about the difference between the sublingual gland and the submandibular gland, not only the difference between them and the brown adipose tissue. So it's easy to differentiate these two from the brown adipose tissue. Why? Because the brown adipose tissue, like I said, zooming in, it does appear the same as this if we just look at it from afar. But zooming in, we can actually see all of these white adipose inclusions as well as lipid inclusions within the brown adipose cells. And that is an easy telling marker of the difference of it being the brown adipose tissue rather than any of the glands, right? But now let's talk about these two and the differences between these two. And it's quite hard to see the difference, I would say. The sublingual gland is obviously closest to the tongue, so this would be the tongue area. So the sublingual gland is closer to the tongue, while the submandibular glands is more towards the bottom of the throat. But again, that is a very hard to tell if you can't navigate yourself correctly. It could also be an upside down slide. It could also be a slide where they don't show you the tongue, so you don't know which one is closer. So again, it all depends. But going back to the sublingual gland, I would say the most prominent differentiator between the sublingual gland and the submandibular gland is that the sublingual gland is a lot lighter than the submandibular gland. So if you see here, it appears almost bluer in color compared to this. So it's lighter, it's also less vibrant than the submandibular gland. If we look at it from this perspective, like I said, the submandibular gland is a lot more vibrant in color compared to the sublingual gland, which appears more bluer or bluish in color than the submandibular gland. And that's because the sublingual glands have more of these mucus acini, which appear a lot lighter than the serous duct, while the submandibular gland has a lot of these darker cells, and less of these mucus acini, lighter structures. Here is another difference. We can see that the sublingual gland appears bluer in comparison to the submandibular gland. And I believe they'll show you both of these glands to compare them before asking you about one specific structure or a name. For the striated skeletal muscle fibers, I'd like you guys to see the difference between this and the brown adipose tissue like you see here, right? So this is the brown adipose tissue, and a lot of people make the mistake of mixing up a cross section of the striated skeletal muscle fiber with the brown adipose tissue. Like I said, there is a difference. First of all, these you can find in around the same area, especially towards the back of the vertebral column. However, the brown adipose tissue have these white inclusions in them, and that is the most important part and the most important differentiator between this and the other structures that we mentioned. Another important part is that usually the immature striated or the striated skeletal muscle fibers are longitudinal. Sometimes they can be cross-cut like they are here, but you can definitely see some longitudinal cuts as well. While for the brown adipose tissue, you can see the clear, well here it's not that clear, but if we compare it with something up here, and this is a very high definition image, and it won't probably look anything like this in the colloquium, it will look more like this, but you can see that these are cells with nuclei and lipid inclusions, like I said, compared to here where you can either see it longitudinal or cross-cut, which is very small in comparison to the brown adipose cell. That is all for class 6. Oh my god. Okay. We're done. I'm gonna do a final test yourself video for embryology. Please watch that. If anything, watch that, because it's actually gonna help you train yourself for the embryology colloq. I did it for colloquium 1 as well. I'm gonna do it for colloquium 2. Wish me luck. It's gonna be a lot of work, but I hope it helps. And if there's anything else you guys would like to know, you could try to ask me, but probably ask your professors. They know the best. They are the best in their field. I'm just here to sort of bastardize the structures and make it as juvenile as possible, so that people can make the connections that they need to make. But when it comes to the real stuff, obviously ask your professors. Thank them also after the colloquiums are over. They're doing a lot more work than I ever manage. So thank you guys, and see you in the next video.